if we add an enemy. And we set this to true. Let's see. Like this. And only the one with the enemy pawn should light up. Yeah, so as you can see here, so it lights up, and that's actually how it is by default now. So if we have no movement left, then we check to all tiles so we can display our entire movement or our entire visibility. Now if we are checking movement at the same time, we only check the tiles which have pawns on them. So you can see that it's like that by default. And I did that because that's pretty quick to calculate anyway. If you only want to check the tiles with pawns on them, it's very quickly done, so you can do it simultaneously when you do the pathfinding. It's different from some of the older versions. And which factions are we searching for? So in the player case, we're searching for enemies. And do we want to display the tiles? Do we want to have a diamond-shaped searching? So let's see. Kind of self-explanatory, I guess, but it's so slow to start up today. Yeah, so it's in diamond shape. There. And we have a max Z difference. That means if we're using height maps, so that some pawns are a lot higher than other pawns, what is the maximum difference we want to be able to search between the current pawn and the target? So this is to prevent someone who has like an attack range of 1 from attacking someone who's standing on a ledge like way up above him but on the next tile. And this is by default set to be a function of dependence on the range of the current pawn. And a minimum range, we can also set that. So let's see. Yeah, so in this case there's a minimum range where you won't have visibility to, so I know that this is used in some games. Right, but how does this work? Find tiles in range. So this is also one of the big important functions, and it can be used for many other things than visibility. For instance, it can be used for an explosion effect, where you set the center of the explosion as the start index and the range is the radius of the explosion, and then you can find all the pawns that are on the indexes that you find, and then you can deal damage to them, for instance. So it can be used for a lot of things, and it's and it is quite a bit different from pathfinding. And I mean, what may seem like makes the most sense is why not just use the pathfinding to find whatever is in range. That's because it's well, it's pretty fast, but it could be even faster when we don't have to care about obstacles or anything. We can make use of some tricks that will make searching a lot faster. This is what I've done. So a few functions are contained here. So first we get indexes in range. This is simply that we find all indexes that are within a certain range of the pawn. We don't care about anything else, firstly. And yeah, so it's also one of the big functions, but there's a lot of stuff that's repeated here. So like in the pathfinding, we set a couple of values depending on the input, so we can reference these easier later. And then we set a few values that are called range check west, range check east, and so on. So if a pawn is standing like this, like in the middle of the map, these will all be equal to his range. So all of these values will be equal to 6. However, if he's standing like this, so he's standing close to this wall, which is, let's see, the north wall, then his range check north will be 2. That means he's only 2 tiles from the top. So this is to tell the function to not search any tiles beyond the top here, which wouldn't make sense. So we set all of these values, we check, we do that by doing some simple math to check how far is the pawn or the current or the start index in this case from the different edges, and we set all these values. And then we start searching for tiles. So let's start with the simple one again. So we, without a hex grid and not a diamond shape, that's the simplest of all, we're searching a square around the pawn. And how do we do this? Well, we first add all tiles from north to south. So this means that we take minus range check north all the way to range check south. This means in this case, or let's take a smaller range. In this case, we're looking at the tiles that are 3 up from in, 3 north, and all the way down to 3 south. And for each of these, we want to check all tiles, or 6 tiles, for every step. And to do this, we have a nested loop, so we have another for loop that goes from negative range check west to positive range check east. This is a bit tricky to explain, I guess, but that's basically what I do to find all those indexes, and you just have to look through this and make sense of it. This one isn't too hard, and then the other ones are a bit more tricky. Actually, I've done this through quite a bit of trial and error, so it would actually be quite difficult to explain without spending ages on it and thinking quite a bit through it myself. So yeah, hopefully this makes sense for you. I'll help you out if you're having any problems with it. But in any case, for all of these tiles, we want to add them to the tiles in range array. So we add each of their indexes to the array, and we also add the distance that each of these indexes are from the start point, which we find by taking the maximum value of the absolute value of each of these loops. Because if we're searching tile number, or we're searching on the loop number -2, for instance, that means it's 2 above us, right? And we're searching east +3, that means that we're searching like -2 + 3, we're searching for this tile. So this tile is, of course, a range of 3, right? From this guy, 1, 2, 3. So we just take the maximum value of these two. That will be the range if we're searching like in a square. And for hexagons and diamond shapes, it is the same basically, though there are some more stuff added in to make sure that it keeps its shape even though you're moving close to an edge. But yeah, it would take some time to explain that, so and I'm not sure I would do a very good job of doing it either. So just look it through, and I hope you'll understand it if you need to understand it. If you need that for your game, then yeah, I'll help you out, like I've said, if you have trouble understanding it. Okay, that's one part of the, let's see, find tiles in range. So now that we've found all of these tiles, then we clear some arrays that we're going to check in the next step. So we first clear all the tile inside range static meshes, instant static meshes, and we clear the range array, which we're going to use later. So we want this to be empty, but we resize it to the size of the map. And we also clear the pawns inside array, so we don't keep that from earlier searches. When we've done that, then we check, will obstacles block visibility? If they do, then we run this one, find visible pawns. If it does not, then we do this other function instead that doesn't check visibility, which is quicker. So we can start with that because it's a simpler version of this basically. We also, for this, we set, do we want to display the tiles? Do we want to, what is the faction we want to search for? Do we only want to find pawns? And all these are, of course, inputs from the original function. So in this case, we get the tiles in range array, which we added in the last step, remember? And for each of those, we check: are we trying to only find pawns here? If we are, then we only want to search this if there is a pawn on it with the appropriate faction. If not, then we want to search everything, so we just search anyway. And then we set the array element of the range array to the range. Oh, this doesn't look good now, but yeah, this should say distance. It says distance here at least. So the range array, we want to save all the distances. The range array is the size of the grid, and it is there so you can simply check by hovering over or clicking a tile, check the range array, how far away is this tile from the current pawn. So we add it to the range array, and we add it to the pawns in sight array as well. So actually the name here is misleading. I mean, if you're checking every tile and not only pawns, then all of the tiles will be added in the pawns in sight array. So it could be maybe named targets in sight array, really. After we've done that, we want to know if we display tiles or not. If not, then we're fine with just adding it to the arrays. And if we do, then again we check if we want to use decals. If we're using decals, we want to spawn a decal at the appropriate location and also add it to the current decals array. And we're getting at the location by getting the index that we're searching at the moment and having it go through the vector field array. And in case we're not using decals, we're adding an tiles in sight range static mesh instance instead. Okay, but what if we want to only find visible pawns or visible tiles, really? Then we do much of the same thing, really. All of this is the same, but this is the biggest change, that we also do a line trace between the index of the current pawn, the index we started searching from, and the index that we're wondering if we have visibility to. And if nothing is hit in between, if nothing blocks range trace, in other words, if the return value of the trace, the range trace is false, then we want to add it. If not, we don't, because it's blocked. And also we want to check the difference in height between the two different tiles, or the index that we start at and the end index we want to search. And we compare this to, let's see, we compare this to the maximum Z difference, or yeah, the maximum Z difference here, maximum height difference, in other words. So if it's the difference is too high between, too large between them, then we also don't want to add it to the range array or the pawns in sight array. Other than that, this is exactly the same as the previous function. Alright, so let's look at the player controller some more. So this video is turning out to be quite a bit longer than even I anticipated, so I hope you haven't fallen asleep yet, though I applaud you if you made it this far. Yeah, like I said, I'm going to add some links below to whatever parts you find relevant, so you don't have to watch the whole thing. But yeah, it will be useful as a reference, hopefully. I spent a lot of time on it in any case. But yeah, so now we have found the tiles in range, and then we set the visibility of the hover marker. So if it has been invisible before, then we set it to be visible now, so you can see which tiles you are hovering over. And that's how that works. So now, after we have done this, that means that we have a can move to array that is filled up, and we also have some tiles in range arrays that are filled up, like the range array. So later now we can check when we click a tile, is this tile in the array that we can move to, is it in the array that we can see, and we can decide what we want to do with that information when we click. So let's look at that. Choose action depending on tile clicked. So this is the input action click. So this is an input action which is contained in the input in the project settings here, where we have the action mappings of the mouse wheel and clicking, as well as the panning and rotation of the camera. So when we click, we want to check, is this the player turn? If not, we don't want to do anything. If it is the player turn, then we check, is the input disabled, which it would be if we're moving, if the pawn is currently moving. So if it is not disabled, then we want to check, okay, let's get the tile that is under the mouse, and see what kind of tile it is. So we use this function, which is also in the grid manager, get hit tile location and index. Now, how does this work? Well, it gets the player controller and gets the hit result under the cursor, just like you would in any click action in any sort of Unreal game, and then we break the hit result, we get the location, and then we run this, we output the raw location itself, but we also output the index, and then we use this vector to index macro, which is here. So this converts the location hit into an index, and this also has two different versions, one for a square grid and one for a hex grid. And I don't think I will delve into this in much detail, but basically it gets the size of the different tiles, and so it divides up the location you hit by the size of the tiles, and then converts that into an index. And it's a bit more complicated on hex grids, because you have to take the offset of the odd and even rows into account, and also that the distance in the y direction is smaller than in the x dimension. But yeah, so it outputs a single index value, which is used later. So now we have an index, we only use the index here, and so we set this to the clicked tile, and we only do it if our trace is a hit. So this is a trace, by the way, the trace is with the path trace. So if we click something and it does not block the path trace channel, then we don't do anything. But if it is, then we set click tile to that index, and then we check the tile that we have clicked. Okay, what is on this tile? So we check the pawn array on that particular index, and we check, is it empty, is it a player, is it an enemy? So first, let's see what happens if it is empty. That means, right, if we click an empty tile, we want to move to it if we can move to it. But if it's outside the move range, we don't want to move to it. That's what we want to do, and that's what all of this is. Yeah, so it's empty. First we said target is pawn. The target we click is not the pawn, right? And then we check, is the tile we clicked within move distance? So does it have a cost in the can move to array? Now all of these looks really weird now, but yeah, you can see here, index cost parent. So if the cost of moving to this is greater than 0, that means that it's possible to reach it. It was added to the can move to array. So that is true, but it also has to be true that the tile we have clicked, or that it's lower or equal to the current move of this pawn. So yeah, so if both of these are true, then we want to move to it. If they're not, then we check, okay, so but it's still, we can still move to it. It's with, or it is within the can move to array, but it's beyond the move range of our current pawn. This is if we have searched beyond the move range of the pawn. So we might want to do something different then. In this case, let's see. So if it is still, so if that is true, it's still in the array, but it's outside of the range. Then we also set target is pawn to false. Why do we do that exactly? I think that might be redundant. Ah, yeah, because of some other stuff here. Yeah, so we set that. That's for a different reason. So if it is outside the move range, which we now know it is, then we get the closest tile to the target instead. And we do that by using this function, which is the reachable index closest to target. This uses the path index array, so we haven't touched on that yet. So yeah, I'll have to get back to this actually. But yeah, so in any case, we find whatever index is closest to the index we have clicked, and we move to that tile instead. So we set that whichever tile is closest to be our new the new target click tile, even though we didn't really click it. I can show how that works actually. So let's just change up this guy's move and let's make him move beyond the move range like this. Let's see. Yeah, oh yeah, we're still using the hex tiles here. But here you can still see the path to all of these, but you shouldn't be able to move to them. So if we're clicking one of these, you see we'll find this tile instead, I think. Yeah, so he finds the closest one instead. That's how that works. Okay. So we set that to be the click tile, and then we run all the movement stuff. Now, if it is not, if it is not within the can move to array either, then we want to just say nothing happens. So we set target is pawn to false. We set disable input to false, so we can click something else because this didn't do anything obviously. Yeah, if the current move of the current pawn is 0 and we click any tile where nothing happens, we want to end the unit turn. You could do this like with an end turn button instead, but that's how I've made it work, so you can see that here. So this is simply that when we have moved all our movement, can't move anymore, we only have the tiles in sight range, and we click any empty tile, then our turn ends. So that's what this is. Okay. But if we have clicked the tile and we can move to that tile, or if we couldn't, but now we found a new tile we can move to, then we set disable input to true. We don't want to be able to click any new tiles and confuse all the pathfinding stuff after we've clicked and have found a tile to move to. So we set the marker location of the target marker, the marker that shows which tile you're moving towards. We set that to be the location of the click tile by using this set marker location function. This is one of the uglier ones. I should spread this out a bit. But yeah, so here you can set either a decal or a static mesh, so it's a bit different depending on each of these. But basically what it does is it runs the index that you're interested in through a vector field array, or through the index to vector on grid function, and then sets the location of the decal or the static mesh to that location. Or if you've inputted a location instead and you've set use index to false, you just use that location, but you also run it through some of these arrays. Yeah. Okay. So when we've set the location of the marker, we set its visibility to true, so we can see it, and we check is the target pawn. That's the thing we checked earlier, right? Which is false in all the cases we've seen so far. In which case the click tile the target index will be the same as the click tile. That's the tile we want to move to. And then when we have found the target we want to move to, we want to find the path within that pathfinding array. So that means we want to look in the CanMoveTo array, we want to look at the index of the target, we want to look at the parent of that index, find the parent of that index, and so on until we get back to the start index, and then we draw a spline or whatever we want between those tiles. So that's what we do with this, which is one of the other big functions within the Grid Manager. So here's what we do. We also have a few inputs, the path end, of course. We don't have the path start because that will always be the start of whatever last generated the CanMoveTo array. Then we have some inputs. Do we want to create the spline? The spline is of course used for displaying the movement path and also moving the pawn along that spline. Do we want to display the path? And if we want to display it, do we want to display it as a spline, or instead, if false, we will display it as instant static meshes, the arrows that I've shown before. So we start by finding the path from the index. So we find it from the index until whatever first generated the CanMoveTo array. So first we clear the path index array, so make sure nothing overlaps or we don't use any of the old stuff, and we set the path holder temp, the temporary variable, to the end index. And then we add the temporary index to the path index array. So this is the first index of our path, is the target we want to move to. And then we get that index and we check the CanMoveTo array, and then we get the parent of that index, and then we make that parent the new path holder temp, the new temporary variable, and then we check. Okay, now we've done that. That is the cost of that tile equal to 0. If it is, that means we have reached the start point, because that has the cost of 0. If it does not have a cost of 0, then we do the same thing again. We check the path holder temporary, which is now the parent of the last temporary, and then we add that, and we check the cost of, or we check the parent of that index, and we check the cost of that, and so on until we have found the first generating index. And after that we have an array that contains the indexes of each of the points of the path. And then we clear the path vector array. Let's see, why do we do that? Oh, I can't remember. I hope it's not important. Maybe it's some old functionality. I'll have to look into that. In any case, let's see. It's always so difficult to go back to whatever it was in before you enter the function. I'll go here. So then we check, do we want to create a spline? If not, we are happy with just having the path index array. This is what we use for most stuff anyway. But do we want to create a spline path? If yes, then we create a spline path. So then we get all the indexes in the path index array, and for each of them we make a path vector array. I should probably clear the path vector array here instead of the old function. But we also add the spline height, and we get each vector and we have it go through the index to vector on grid function, so that we get locations instead of indexes. So we can create, because we need to have vector locations to create a spline, right? And we have the height of that spline. Yeah. Okay, so here we have an array that is basically identical to the path index array, just instead of indexes we have locations. And this shouldn't be connected actually. I have to remove that. That doesn't matter in 4.7, but in 4.8 and onwards that makes a difference. So that shouldn't be there in later updates. Okay, so when this is completed, we add the current pawn's index to the spline path as well, because the current pawn's index is not part of the path index array. So we need to add that manually. So we're getting the current index, and we're adding it to the path vector array. And then we set the spline world points. This is a function that comes with Unreal, of the path spline. So we set all the points of the spline to be the points that we have in our path vector array. So now we have created a spline, and we have some outputs, just in case you'll need that. I'm not using it though, but it's useful at a glance to see what is made within this spline path. Okay. Then we check, do we want to display this path? If not, then we just stop here. We have our spline, it's invisible, but we're not going to display it. If we want to display it, do we want to display it as a spline or as instant static meshes? If we want to display it as a spline, we do it like this. Yeah, this is not my strong suit, but in any case, we start here by destroying and clearing the spline path. So we get all, we have this spline mesh array, which contains all the spline meshes from our previous spline, if we already had a displayed spline. And for each of these, we destroy the component, and then we clear the array. Yeah. So after we've done that, then we have a for loop that runs for as many loops as the length of our spline divided by let's see, divided by the length of our spline mesh. And the length of the spline mesh, if you remember, was set in our grid manager to be dependent on the size of our default tile meshes. But yeah, so we run a loop, and for each and through this loop, what we want to do really is to add a lot of spline mesh components that constitute the entire spline. So the spline is like invisible, just based on math, but it contains a lot of small segments, small meshes that are bent along the spline. So we want to add all of those small mesh components, basically. So we do that a number of times, yeah, like I said, depending on the size of the spline and the size of the spline mesh. And for each of these loops, we add the spline component, a spline mesh component, and we set its static mesh to be the spline path mesh, which is set in the public variables. Then we set its material to be white emissive, which is the default I've chosen. And then we add that component to the spline mesh array, so it can later be deleted in this function. And then we set the start and end points of that particular spline segment. Yeah, which we do by getting each of these segments, where we take the index and we multiply it by the spline mesh length. So for index 0 we get the first segment, for index 1 we get the one that's the distance of one spline mesh from the beginning, and so on. So we get all these little components. And for each of them we get their world location and distance along the spline, to generate the spline itself. It's been a while since I made this, so that's how well I can describe it, I think, but that's basically how it works. Okay, and if we want to display it as instant static meshes instead, and it's a bit simpler, we clear all the path meshes, which are the little arrows, and then for each loop in the path vector array, we spawn one of these little path meshes. And yeah, the location Z, that should be changeable from outside. Yeah, well, I'll change that later. And we set the rotation to point to the last point of the path vector array. So we get the path vector array, and we find the one that's before the one we're spawning a mesh for now. And then we're finding the look at rotation between whatever mesh we are currently placing and the mesh we placed last. So that's how that works. Okay, I think that's the entire find path within pathfinding array function. Also an important function. After we've found that path, Then we set has acted this turn to this pawn to be true. This is to make so that after he has acted, if we can split up the move, so we can move a bit and then move some more, that we can't, if we are able to switch to another pawn, we are not allowed to do that after he has moved a bit. And yeah, it's also used for some other stuff. After that, we just to make sure and then we clear all the in-range mesh markers, and we destroy and clear the spline path so that all these little blue meshes and the spline path doesn't remain after we or when the pawn is moving. Looks better that way, I think. Okay, and then we set the array element of the current pawn, which we get from the game mode, and we find the index, and in the pawn array we make that index empty, because now that pawn has left that index, so there should not be a pawn in it anymore. And we do the same thing for the pawn actor array. In this case we set the array element to nothing. There is no pawn contained on that index anymore because the pawn has left. And then we begin the movement of that particular pawn, which is called, let's see, because that's continued in the event graph of unit parent. So the target is unit parent, so we'll go to that later. That's the physical movement itself. And then we set the visibility of the hover marker to be false, because we don't want to show that while we're moving, or that's how I prefer it in a way. And we check, can our pawn split up move? That means when we have moved part of its movement, will we allow it to move, be able to move more afterwards? So if it can split up move, we set the current move of this pawn to be equal to whatever was its current move before, minus the cost of moving to its new target. Now if we don't want it to be able to move afterwards, then we just set its current move to 0. It's used up. And in the end we also clear up the can move to array. Might be unnecessary because we do that in the pathfinding, but I do it just to be sure. Okay, there was some more stuff here I didn't go to. So if the target is pawn, yeah, that hasn't happened yet. So let's first go to this. We click something and it's not empty. It's actually an enemy. So what we do then, a lot of different things can happen in that case. So is the target within attack range? This means when we check the range array that we generated in the find tiles in range function, if you remember, if this is higher than 0, that means that it does have a range to that tile, and that we can attack it directly from where we're standing. So if it does, then we disable input, we clear all our meshes and the spline path, and then we attack victim, which is also a function within the unit parent, so we'll look at that later. And then we make sure it's not idle anymore, because it's attacking. But if it is not within our range, then we set target is pawn, because maybe we can move to and attack that pawn, even though we can't reach it at the moment. So we set target is pawn, and then we do our whole checking here. Okay, can we move to it and all of that. So now we can move to it. And yeah, if we click an enemy and it is outside our move range, then we can set target is pawn to false, because we're going to move to the closest tile, right? So the target is not pawn. But if we can move to it, as found out by this branch, then we do much the same as we did before, but now target is pawn is true, right? So we don't want to move to the target we have clicked, because then we would be standing on the same tile as a target. So we want to be standing at the tile in front of our target instead. So then we check if we clicked this pawn, is it adjacent to us? So if it is, we don't want to start moving towards it. This is just a safety feature, really. It should never fire true. And then we get the path index array, and we get index number 1. So remember, index number 0 was the target. So index number 1 is the is the index or tile in front of that target. So we set that to our target index and move towards that instead. So that's that. Okay, so that's both of these. Now, to end it, if we are clicking a tile and there's a player pawn on it, what do we do then? Well, that depends really. So